In this problem, we have a square piece of cardboard. Let me erase the inside parts for a second. Okay, so there's your square. It's a square piece of cardboard, and each side has length 12 centimeters. Now you're going to form this into a box, and I did my best at drawing the box at the bottom. I wish that you were in the actual classroom with me because I do actually fold up a piece of paper to show you the box that it makes. But cut out, go ahead, take a piece of paper and cut out little bitty squares from it, and you can fold it up and it makes a box with an open top. Now what you notice about these squares is they're of size X. So this piece would be X, and this piece would be X, and this piece would be X, and this piece here would be X, and so forth. So we have this square piece of cardboard. We're forming a rectangular box. What value of X would maximize volume? So we're looking for max volume. Okay, so the volume of a box is length times width times height. Okay, length times width times height. Just like with all of our other problems we've done so far, we need volume in terms of one variable instead of three. So we have to do some work with that. Now, here's what's special about this box. So I'm going to cut out these corners of the box. So when I cut out the corners, it's going to leave these three pieces here. Well, that's going to be this part of the box. That's where it goes. So if you look at that blue piece right there, that's the whole side, 12, with two x's cut out. So this side of the box would be 12 minus 2x, and this side of the box would be 12 minus 2x. When you actually fold up the box, this little piece right here, that's your size X. That's where you actually folded it up, so that makes the height of the box. That makes the height of the box. So that's how you're going to find your dimensions. You have 12 minus 2x on one side, 12 minus 2x on the other, and volume, your height rather, is X. So again, how we got it, just one more time. If we took this whole side 12, and we took out this little piece here, and we took out this little piece here, what would be left would be 12 minus 2x. Okay, so this is the formula that we're going to be using. Let's go ahead and multiply it out. So this would be 144 minus 24x minus 24x plus 4x squared. Okay, so that's the first two terms multiplied together, and then we'll multiply it through by x. 24 and 24 would give us a 48. Okay, and that's the formula for which I want to optimize. We have to set the derivative equal to 0. Okay, let me double check my formula real quickly. Oh, it's good. So let's take the derivative. When we take the derivative, we get 144 minus 96x plus 12x squared. We're going to set that to 0. Right, what I know about this polynomial here is that they have a common factor of 12. So I can factor a 12 out of each one of these. Okay, now that looks fine, and there's nothing wrong with it. I just prefer my x squared to be written first. So this, what you see in parentheses here, I'm just going to write in descending order. I'm not changing it at all. I'm just writing it in a usable form. When I get ready to factor it, the factors of 12 that add to give me 8 are 6 and 2. They're the same sign, both negative. I can divide both sides by 12, and that gets rid of the 12. And then I'll set my factors equal to 0. So x would equal 6, and x would equal 2. So those are my critical numbers. So what I'm going to do is I'm going to take 6 and 2, and I'm going to plug them into this volume function to see x equals 2 and x equals 6. I'm going to plug this into our volume function to see which one would give me the largest volume. So volume would be 144 times 2 minus 48 times 2 squared plus 4 times 2 cubed. When I put all of that into my calculator, I get 128. Okay, so I'll also plug in the 6. When I plug in the 6, I'll get 144 times 6 minus 48 times 6 squared plus 4 times 6 cubed. So when I plug those in, I get 0. Now those were my two critical numbers, but what I did forget to do, or I just kind of left out, was I didn't talk about it over the domain. So let's go back over that one more quick second. So the particular variable that I'm using here is x. And I know that x is a distance, so x has to be positive. I also know that 12 minus 2x, that's my other side, that's a distance, so that has to be positive. So negative 2x is greater than or equal to a negative 12. If I divide both sides by negative 2, I get 6, and I had to flip my sign. So it told me that x had to be between 0 and 6. I've already plugged in the 6, so that didn't work. And if you plugged in 0, you get 144 times 0 minus 48 times 0 plus 4 times 0 cubed. You get that the volume equals 0. So the domain didn't really help me any in this problem. Most of the time, it won't help you. So if you look back at our problem, 128 was my maximum volume. It says what value of x will maximize the volume. So the value of x that maximizes the volume is 2. That's your answer because that's what the question says. Now let's go ahead and attack any question that you would get here. So it might ask you what's the value of x. It might also ask you what are the dimensions of the box. Well, this box has size 12 by 2x, 12 by 2x, and x. Those are your dimensions, length and width and height. So if it asked you for the dimensions, which it didn't, but if it asked you for the dimensions, you could plug 2 into these values. When you do that, you would get 12 minus 2 times 2, which would be 12 minus 4, which gives you an 8. So it would be 8 by 8 by 2. Those would be the dimensions if it happened to ask you for the dimensions.